And I'm going to give you a definition, but I don't really think we need to write the definition down. Probably what I would write if I were you would be these examples, okay, so that you have something in your notes that are examples of polynomial functions. So a polynomial function it's just like, for example, a quadratic where you have an x squared as your highest power, or you could have a function where you have an x cubed as your highest power, or so forth. So anything that looks like the examples in this sort of tannish box would be an example of a polynomial function. So notice that you can have coefficients that are negatives, you can have positives. I didn't put any fractions, but you can have fractions as well. You can have decimals. Any of that should be fine. All right, so I'm going to give you a minute to just write down some examples of the polynomial functions, and then we'll move on. Anybody feel like you need more time or ready to move on? Just tell me if you need more time. Okay. All right, so there are a couple other terms that we need to sort of get down before we get started. Most of what we're going to be doing in this section and really in this chapter is finding what we call zeros. All right, so when they talk about the term zero, what they're really talking about is the x-intercepts, okay? Same thing. Zeros are the same thing as the x-intercepts. Now, they're written a little bit differently. We've talked in class about the x-intercepts being written with an x comma y, like a coordinate. If you're talking about a zero, you're just going to write that x is equal to whatever number you have. Okay, so not as a coordinate, but it's referring to the same thing on the graph. When they talk about a zero, they're talking about the x-intercept. All right, so make yourself a note of that that's the same thing. All right, the next term that we need is the term degree. And the degree is equal to the highest exponent in the problem, as long as your problem is not factored. Okay, so we mean when the thing is multiplied out, the degree is the highest power. All right, so I'm going to back up for just a second. I'm coming back, okay? But like this problem right here, that problem has a degree of 3 because that is the highest exponent in the problem. All right, this one has a degree of 4 because it's the highest exponent in the problem. It has to be written out in that format in order for me to pick out the highest exponent. If it's factored, I'm going to have some difficulties with that. Okay, and we'll talk about that as we look at some problems. All right, so degree is your highest exponent, not in factor form. All right, and then the last thing you want to jot down is that the number of zeros is equal to the degree. Okay, so that's helpful for us as we start finding zeros if we know right when we start how many zeros we're supposed to be finding. All right, anybody need more time on copying there? All right, so let's look at an example. All right, now we're going to start really, really easy here, just so we can get an idea of what we're doing before we get to a harder problem. All right, so we have this function, x squared plus x minus 6. And the first question asks us for the degree. Okay, so that part should be fairly easy, right? We're looking at the highest exponent in the problem. So the highest exponent is 2. So my degree will be 2. Right? And then how many zeros will the function have? Remember that that's the same as the degree. So if the degree is 2, we're expecting to have 2 zeros as well. Okay, so now we need to find the zeros. So I'm reminding myself that the zeros are the same as the x-intercepts. So, all right, you guys talk to me for a minute. So how would I take a function like this and find the x-intercepts? What would I need to do?
Set it equal to 0.
Good. Set it equal to 0. So remember that when we're finding the x-intercepts, that means that the y value is 0, right? So this is the y value in the problem right here. So I'm going to set that equal to 0. Okay, and then I'm going to work at solving that, right? So if you need that note, I'll jot it down. X-intercepts, you're going to set the y equal to 0. Okay, and then we try to solve it. So this one's quadratic. We know that we have a bunch of choices for a quadratic that we've talked about. We've talked about factoring. We've talked about quadratic formula. We've talked about completing a square. I think in this case, because this is a very easy problem, I'm going to go ahead and just see if I can get it factored fairly easily. Right? So when I look at my first term right here, I know that this has to be x and x in order to make the x squared. Okay, and for the 6, I could do 1 times 6 or I can do 3 times 2. But remember that you want to pick one that's going to give you a 1 in the middle. So probably the 3 and the 2 would combine easier to make 1. Right, so I'm going to go ahead and use the 3 and the 2 there. Right, and then I may just have to play with my signs a little bit. I want that 1 in the middle to be positive, which means that my bigger number probably should be positive, and my smaller number should be negative. All right, so we have done that in class, talked about the factoring. Does everybody feel okay about what I just did with that? Anybody have a question? Okay, all right, so once we get it factored, then remember that to find the solutions, you set each part equal to 0. So you come off to the side somewhere and you say x plus 3 is equal to 0 and x minus 2 is equal to 0, and you solve. Okay, so, easy enough, subtract the 3. So we have x is equal to negative 3. Add the 2 to both sides. We have x is equal to 2. All right, so these are the 2 zeros. X equals negative 3 and x equals 2. Okay. All right, and I didn't put the graph up here for you to see because I figured it was easy enough. I would just graph it on my calculator and sketch it real quick. So this graph does a parabola that looks like this. Okay, so you can see from that graph that it crosses the x-axis at 2, and it also crosses the x-axis at -3. Right, so your zeros are very easy to check, especially if you have a graphing calculator. You can just graph it and make sure that you've got the zeros correct. Okay, so easy problem. Anybody have a question there? Kind of laying that foundation. Okay, all right, so I'm going to assume if you guys don't say anything that means we're good to go. And again, just put it in the chat if you don't want to say it out loud. Either way is fine. Okay, so the next question says for us to find the function that has degree 3 and has these zeros. Okay, so I want to go back to that previous problem just for a second. Now that we kind of see where we're heading, I want to point out one thing to you. Okay, so I'm coming back, but let's go back to this just for a second. Look at your factor and the zero that goes with it. Okay, and notice the relationship between the positives and the negatives. All right, so if in the factor it's a +3 right here, the zero becomes a -3. All right, and we see that happening on the other one as well. So if you look at this one and kind of pair it up with that factor, here you have a -2, and here this is a +2. So you have sort of this opposite relationship between the factor and the zero. Okay, so keep that in mind. All right, so if I'm going to write a function that has a zero of -3, what is that factor going to look like that goes with it? What goes inside that parenthesis to match up with the -3?
A +3.
+3, right. So we're going to do x + 3. All right, and that's going to match up with the -3. Okay, and then we'll do the same sort of thing with the +2. All right, so the +2, 0 becomes a -2 in the factor. Okay, and then same thing with the 5. We'll have x -5 because this 5 is positive on the 0. Now, the only other thing I need to check is I need to be sure that my degree is 3. Okay. So we can check that in a couple of ways. One way is I can actually multiply this thing out, which I don't guess I really mind doing, but I'm not excited about multiplying it out, especially as it gets bigger. Okay. The other thing is I think I could do is maybe just start multiplying it out. All right, so let me ask you this question. If I start multiplying this x times that x, I know that that's going to be an x squared, right? And then if I multiply that x squared times another x, that's going to give me x to the 3rd. So I don't really know what else is going to come in this thing. And it doesn't really matter. But what I do know is that the first term will be x to the 3rd. Okay, and the easiest way for me to tell you to do that is if you've got this thing factored and you need to figure out your degree, just count your x's. Okay, so we look at this and we say 1x, 2x's, 3x's. It should translate into an x to the 3rd. That's going to give me my degree of 3, and so I'm all set. Now, nowhere in this problem does it say I have to multiply it out. So I'm going to go ahead and go with what I have right here as my answer. Okay, that's a polynomial function. It has degree 3. It has the zeros that we wanted.